Fuses are crucial components in electrical systems designed to protect circuits from overcurrents. When a power pole fuse blows, it's a sign that the current flowing through that circuit exceeded the fuse's rated capacity. Typically, a blown fuse must be replaced with a new fuse of the same rating to restore power. Fuses operate on the principle of melting. Inside each fuse is a thin wire or filament specifically designed to melt and break the circuit when the current surpasses a predetermined level. The physical construction of a fuse facilitates both its operation and its replacement. The fuse is mounted within a fuse holder, which provides the necessary electrical contacts to integrate it into the circuit. This holder also features a mechanism for easy insertion and removal of the fuse. Spring-loaded contacts within the fuse holder hold the fuse securely in place, ensuring a reliable electrical connection under normal operating conditions. The fuse is typically attached to the fuse holder with a pivot point at the bottom. This pivot allows the fuse to swing out of the holder when it blows, making it easy to identify and replace. When an overload occurs, the fuse wire melts due to excessive heat generated by the high current. The melting process creates pressure from the melted metal, which then forces the fuse out of the contacts, effectively breaking the circuit. The spring-loaded contacts play a crucial role in ejecting the blown fuse from the holder. This ejection mechanism serves two important purposes. Firstly, it helps to visually indicate that the fuse has blown, as the fuse will hang down from the holder, and secondly, it prevents the blown fuse from simply falling, ensuring safety and facilitating easy replacement. It's important to note that while linemen may sometimes appear to reset the original fuse by reinserting it into the holder, this is generally done only for testing purposes to confirm the fault has been cleared or in situations where the fuse was not actually blown. Always remember that fuses are rated for specific electrical currents. Using a fuse with a higher rating than the circuit requires is extremely dangerous, as it can lead to overloads and potentially cause fires or equipment damage. It is therefore crucial to always replace blown fuses promptly and with the correct rating to maintain electrical safety and prevent further damage. The amperage rating of a fuse is usually printed on the fuse itself. To determine the correct fuse size for a circuit, you need to consider the load that the circuit will be carrying. The fuse should be sized to protect the wiring in the circuit, not necessarily the equipment connected to it. The National Electrical Code, or NEC, provides guidelines for determining the appropriate fuse size based on the wire gauge and the type of load. For example, NEC Table 310.15b16 specifies the allowable ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air, based on the conductor size. A 14 American wire gauge copper conductor, typically used for 15 amp circuits, has an ampacity of 15 amps when rated for 60 degrees Celsius, 20 amps when rated for 75 degrees Celsius, and 25 amps when rated for 90 degrees Celsius. Similarly, a 12 American wire gauge copper conductor, commonly used for 20 amp circuits, has an ampacity of 20 amps at 60 degrees Celsius, 25 amps at 75 degrees Celsius, and 30 amps at 90 degrees Celsius. A 10 American wire gauge copper conductor, often used for 30 amp circuits, has an ampacity of 30 amps at 60 degrees Celsius, 35 amps at 75 degrees Celsius, and 40 amps at 90 degrees Celsius. When selecting a fuse, you should choose one with a rating that is equal to or slightly less than the ampacity of the wire, but not less than the non-continuous load plus 125% of the continuous load. For example, if a circuit has a continuous load of 10 amps, the fuse should be rated at least 10 amps plus 125% of 10 amps, which equals 22.5 amps. In this case, a 20 amp fuse would not be sufficient, and you would need to use a 25 amp fuse, assuming the wire is rated for that amperage. However, the maximum standard overcurrent protection device for 14 American wire gauge is 15 amps, for 12 American wire gauge is 20 amps, and for 10 American wire gauge is 30 amps, regardless of conductor insulation temperature rating per NEC 240.4d. It's crucial to understand the difference between different types of fuses. There are several types of fuses available, each designed for specific applications and with different characteristics. Firstly, cartridge fuses are one of the most common types of fuses typically used in residential, commercial, and industrial applications. They consist of a cylindrical body with metal contacts at each end and are available in a wide range of voltage and current ratings. Secondly, plug fuses, also known as Edison-based fuses, are typically used in older residential electrical systems. They screw into a fuse holder similar to a light bulb and are available in ratings up to 30 amps. Thirdly, blade fuses, also referred to as spade fuses, are commonly used in automotive and electronic applications. They have a plastic body with 2 or more metal blades that plug into a fuse block or holder. Fourthly, time delay fuses, also known as slow blow fuses, are designed to withstand temporary overloads without blowing. They have a built-in delay that allows them to handle inrush currents, such as those produced by motors or transformers, without interrupting the circuit. Fifthly, fast-acting fuses are designed to blow quickly in response to an overcurrent. They are used in circuits where even a short duration overload could damage sensitive components. Sixthly, current-limiting fuses are designed to limit the amount of fault current that flows through a circuit during a short circuit. They operate by quickly introducing a high resistance into the circuit, which reduces the current flow and prevents damage to equipment. Lastly, resettable fuses, also known as pulley fuses or self-resetting fuses, are devices that automatically interrupt a circuit during an overcurrent condition and then automatically reset once the overcurrent condition is removed. They are commonly used in electronic devices to protect against short circuits and overloads. When dealing with fuses, it's important to observe some essential safety precautions. Firstly, always disconnect power to the circuit before replacing a fuse to avoid electrical shock. Secondly, never replace a fuse with one of a high rating, as this can overload the circuit and create a fire hazard. Thirdly, inspect the fuse holder for any signs of damage or corrosion before installing a new fuse. Fourthly, if a fuse blows repeatedly, it's a sign that there is a problem with the circuit that needs to be investigated by a qualified electrician. Fifthly, always use fuses that are approved by a recognized testing laboratory such as Underwriters Laboratories or Canadian Standards Association to ensure that they meet safety standards. Lastly, store spare fuses in a dry place and out of reach of children. Understanding how fuses work and following these safety precautions is essential for maintaining a safe and reliable electrical system. It's also worth noting that fuses are not the only type of overcurrent protection device available. Circuit breakers are another common type of overcurrent protection device that is often used in place of fuses. Circuit breakers are similar to fuses in that they are designed to interrupt a circuit during an overcurrent condition, but they operate differently. Instead of melting a wire, circuit breakers use a mechanical mechanism to trip and break the circuit. Circuit breakers have several advantages over fuses. Firstly, they can be reset after they trip, whereas fuses must be replaced. Secondly, they provide better protection against short circuits and ground faults. Thirdly, they can be easily tested to ensure that they are functioning properly. However, circuit breakers also have some disadvantages. Firstly, they are more expensive than fuses. Secondly, they can be more difficult to install and maintain. Thirdly, they may not provide as much protection against small overloads as fuses. When choosing between fuses and circuit breakers, it's important to consider the specific application and the level of protection required. Fuses are typically used in applications where cost is a major concern and where the risk of a short circuit or ground fault is low. Circuit breakers are typically used in applications where safety is a major concern and where the risk of a short circuit or ground fault is high. Regardless of whether you use fuses or circuit breakers, it's important to ensure that they are properly sized and installed to provide adequate protection for your electrical system. Overcurrent protection is a critical component of any electrical system, and it's essential to understand how it works and how to maintain it properly. Let's delve deeper into the types of fuses available in the market. There are single-element fuses and dual-element fuses. Single-element fuses are basic fuses that provide overcurrent protection. They have a single conductor that melts when the current exceeds the fuse's rating. These fuses are suitable for general-purpose applications where there are no significant inrush currents. Dual-element fuses, also known as time delay fuses, have two elements: a short-circuit element and an overload element. The short-circuit element is a thin wire that melts quickly to protect against short circuits. The overload element is a spring-loaded mechanism that opens after a time delay to protect against overloads. These fuses are suitable for circuits with motors, transformers, and other inductive loads that have high inrush currents. Furthermore, fuses are categorized by voltage and current ratings. Fuses are available in a wide range of voltage and current ratings to suit different applications. The voltage rating of a fuse indicates the maximum voltage that the fuse can safely interrupt. The current rating of a fuse indicates the maximum current that the fuse can carry without blowing. When selecting a fuse, it's important to choose one with a voltage and current rating that is appropriate for the circuit it will be protecting. The voltage rating of the fuse should be equal to or greater than the voltage of the circuit. The current rating of the fuse should be equal to or slightly less than the ampacity of the wire in the circuit. Also, fuses have interrupting ratings. The interrupting rating of a fuse is the maximum amount of fault current that the fuse can safely interrupt. Fault current is the current that flows through a circuit during a short circuit or ground fault. When a fault occurs, the current can rise very quickly to very high levels. If the fuse does not have a high enough interrupting rating, it may not be able to safely interrupt the fault current, which could result in damage to equipment or injury to personnel. When selecting a fuse, it's important to choose one with an interrupting rating that is high enough to handle the maximum fault current that could occur in the circuit. The interrupting rating of a fuse is typically marked on the fuse body. Finally, fuses have agency approvals and certifications. Fuses are typically approved and certified by independent testing laboratories such as Underwriters Laboratories and Canadian Standards Association. These agencies test fuses to ensure that they meet safety standards and performance requirements. Fuses that have been approved by a recognized testing laboratory will be marked with the agency's logo or symbol. When selecting a fuse, it's important to choose one that has been approved by a recognized testing laboratory to ensure that it meets safety standards. It is also important to consider the ambient temperature when selecting and installing fuses. The ambient temperature is the temperature of the air surrounding the fuse. Fuses are designed to operate within a specific temperature range. If the ambient temperature is too high, the fuse may blow prematurely. If the ambient temperature is too low, the fuse may not blow when it should. When selecting a fuse, it's important to choose one that is rated for the ambient temperature in which it will be used. In addition, consider the altitude. Altitude can also affect the performance of fuses. At higher altitudes, the air is thinner, which can reduce the cooling capacity of the fuse. This can cause the fuse to overheat and blow prematurely. When selecting a fuse for use at high altitude, it's important to choose one that is derated for altitude. Derating means reducing the current rating of the fuse to compensate for the reduced cooling capacity. The derating factor will vary depending on the altitude and the type of fuse. Moreover, consider fuse coordination. Fuse coordination is the practice of selecting and coordinating fuses in a way that ensures that the fuse closest to the fault will blow first, while the other fuses in the circuit remain intact. This helps to minimize the extent of the outage and to protect equipment from damage. Fuse coordination is typically achieved by using fuses with different time current characteristics. The time current characteristic of a fuse is a graph that shows the amount of time it takes for the fuse to blow at different current levels. By selecting fuses with different time current characteristics, it's possible to ensure that the fuse closest to the fault will blow first. Another element is the fuse holder. The fuse holder is a device that holds the fuse in place and provides electrical connections. Fuse holders are available in a variety of sizes and styles to suit different types of fuses. When selecting a fuse holder, it's important to choose one that is compatible with the type of fuse being used and that is rated for the voltage and current of the circuit. The fuse holder should also be installed in a location where it is protected from physical damage and moisture. Installation practices of fuses are important. When installing fuses, it's important to follow the manufacturer's instructions carefully. Fuses should be installed in a location where they are easily accessible for inspection and replacement. The fuse holder should be properly grounded to prevent electrical shock. The fuse should be installed with the correct orientation. Some fuses have a specific orientation that must be followed in order for them to function properly. Also, make sure to inspect the fuses regularly. Fuses should be inspected regularly for signs of damage or corrosion. If a fuse is damaged or corroded, it should be replaced immediately. Fuses that have blown should also be replaced immediately with a fuse of the same type and rating. Never replace a fuse with a fuse of a higher rating, as this could create a fire hazard. Keep in mind the troubleshooting process of fuses. If a fuse blows, it's important to troubleshoot the circuit to determine the cause of the overload. The overload could be caused by a short circuit, a ground fault, or an excessive load on the circuit. Once the cause of the overload has been identified, it can be corrected and the fuse can be replaced. If the fuse continues to blow after the overload has been corrected, there may be a more serious problem with the circuit that needs to be investigated by a qualified electrician. Different applications have different requirements for fuses. For example, in residential applications, fuses are typically used to protect lighting circuits, appliance circuits, and other branch circuits. In commercial applications, fuses are typically used to protect lighting circuits, motor circuits, and other equipment circuits. In industrial applications, fuses are typically used to protect motor circuits, transformer circuits, and other high-voltage circuits. The type of fuse that is used in a particular application will depend on the specific requirements of the application. In addition, renewable energy systems use fuses. Fuses are also used in renewable energy systems such as solar power systems and wind power systems. In these systems, fuses are used to protect the inverters, batteries, and other components from overcurrents. The fuses used in renewable energy systems must be specifically designed for these applications and must meet the requirements of the National Electrical Code. In conclusion, fuses are an essential component of electrical systems, providing critical overcurrent protection. Understanding the principles of operation, types, ratings, safety precautions, and troubleshooting techniques is vital for maintaining safe and reliable electrical installations. Regular inspection, proper fuse selection, and adherence to safety guidelines are paramount to prevent electrical hazards and ensure the longevity of electrical equipment.